Using r and theta, multiplication of complex numbers in their exponential form is similar with the procedure when the complex numbers are in their polar form. Learn about it here in Mathematics of Engineering. The exponential form of complex numbers is z as equal to the modulus r times e raised to I times the argument theta. When multiplying complex numbers in this form, observe the laws of exponents, specifically one where e raised to a times e raised to b can be taken as the same base e where the exponents are added. This is the product rule. The first example is to take the product of z with w if z is 3 times cosine of pi over 6 plus I times sine of pi over 6, and w as 2 root of 3 times cosine of pi over 8 plus I times sine of an 8 of pi. The complex numbers are both in polar form, so taking z times w looks long. But when they are placed in exponential form, zw is just 3e raised to I times pi over 6 times 2 root of 3 times e raised to I times pi over 8. The moduli are two different figures, which can be multiplied to 3 times 2 root of 3. The next term is base e with two different exponents, and with the product rule, the exponents of the same base can just be added, making e raised to I by pi over 6 plus I times pi over 8. With two different denominators, the LCD should be taken to create a single argument. The least common denominator for 6 and 8 is 24. Create equivalent fractions and get 4 pi over 24 plus 3 pi over 24, which gives the resultant complex number as 6 root of 3 times e raised to I times 7 pi over 24. Another example has z as 7e raised to I times 7 pi over 6, and w as 4e raised to I times 5 pi over 8. We determine the product zw, graph it, and provide its Cartesian form. Zw is then 7e raised to I times 7 pi over 4 multiplied by 4e raised to I times 5/3 of pi. We take the modulus as 7 times 4. The second terms e have their exponents added, that is I times 7 pi over 4 plus I times 5 pi over 3. With varying denominators, take the LCD, which is 12. Take the equivalent fractions and get 21 pi over 12 and 20 pi over 12, added together to have 41 pi over 12. The resulting z is then 28e raised to y times 41 pi over 12. These can be graphed in a manner where we break down the argument into revolutions. 41 over 12 can be 24 over 12, which is 2 pi or 1 revolution. There can also be 12 pi over 12 from the remainder, and that is half a revolution. The remaining part is 5 pi over 12, which locates the vector in the third quadrant, having 5 pi over 12 angle from the x-axis. It is also noted that the vector has a length of 28 units signified by the modulus. With the vector already located, take the x component, which is actually the real number, from 28 cosine of 5 pi over 12, which gives 7 root of 6 minus 7 root of 2. In decimals, the real number is 7.2469. For the y component, which is the imaginary part of the complex number, b is 28 sine of 5 pi over 12, which gives 7 root of 6 plus 7 root of 2, or 27.0459 in decimal form. Thus, ZW is then negative 7.2469 as it points to the left, and negative 27.0459 as the component points downwards. The Cartesian form of the resultant can also be solved through its polar form. As z is 28e raised to y times 41 pi over 12, the modulus is 28 and the argument is 41 pi over 12. Place these figures in the polar form to get z as 28 times cosine of 41 pi over 12 plus I sine of 41 pi over 12. Multiply the terms and get negative 7 root of 6 plus 7 root of 2 for the first term, and negative 7 root of 6 minus 7 root of 2 for the second product. In decimals, z is negative 7.2469 minus 27.0459i, which is similar with the answer earlier. Let's try multiplying three complex numbers in their exponential form. With the complex numbers tagged as w, y, and z, the product w, y, z is solved by multiplying them all together, where the moduli will just be multiplied 2 by 6 by 3 as 36. The exponents of e will then be added. That would be half of pi, 4/9 of pi, and 3/8 of pi. Take the least common denominator to add the exponents up, and with 2, 9, and 8, the LCD is 72. So the equivalent exponents are now 36 pi over 72, 32 pi over 72, and 27 pi over 72. They are then simplified to have the complex number w, y, z as 36 times e raised to y times 95 pi over 72.